Getting into software engineering in 2026 is a whole different conversation from what it was 3 years ago. AI tools can write code, can debug errors, can generate boilerplate. So the questions that a lot of people are currently asking are, what still matters? What's still worth learning? And what's changed? Hey, I'm Becca. I'm a software engineer and I use AI tools daily at work. In this video, I want to give you the honest answer. The things that matter more now because of AI, the things that maybe haven't changed, and also the things that are really easy to skip, but might cost you in the long run. I got into software engineering before AI tools looked anything like they look now, before we had Claude and ChatGPT and all of these tools in our daily workflows. I don't have a computer science degree, I don't have the traditional technical background, and I figured out a lot of this stuff without a specific roadmap. And now I use AI tools daily. So I can speak to what the foundations were before, what I still rely on now, and also the advice I'd give to someone if they were entering the industry in 2026. These are the 7 things that I think are the most important. So let's get straight into it. Understand the fundamentals underneath the frameworks. This is the one that matters most right now, especially with AI in the picture. And I'll explain why I think it's become even more important, despite the fact that we have AI to do a lot of the fundamental stuff for us. AI tools are very good at generating code. They can write functions, they can write tests, they can suggest different libraries, and they can explain different syntax errors. What they might not necessarily be as good at is higher level architectural decisions or subtle bugs or subtle logic issues. Or maybe they're not as good at recognizing where they've written code that is technically correct, but maybe incorrect for your specific use case and your specific context. That requires a human who has that context, who knows those fundamentals, who is able to steer the AI in the right direction. The tech industry moves so fast. There are always new and emerging technologies. What was the in thing or the popular thing 3 years ago is now legacy. Or same thing, what's popular today, maybe legacy in 1 year's time. We don't know how the future is going to be. All we know is that things will change and they change fast. But what doesn't change are your underlying fundamentals. So you always need to know how data structures work, how algorithms work, how networks work, or memory. And these are the things that carry across whatever language and will more than likely still be relevant in the future. You need to be able to understand these foundations for yourself so that you are able to recognize if AI is doing the wrong thing or AI is taking you completely on the wrong path. We all know that AI isn't correct 100% of the time, and you need to be confident in your foundations in order to steer AI in the right way. For example, if you'd understand why you'd maybe use an index instead of scanning an entire database table, then you'd be able to understand for yourself why a query may work in testing or staging environments, but fail when you get to production because of the large amounts of data there. That's just one example, but there are so many cases where it's better for you to have that understanding of the fundamentals and the basics before just fully trusting AI with everything. You want to be able to be confident in your decisions. The engineers AI makes redundant are the engineers who just blindly copy code, who just write out code without fully understanding what's going on. Whereas the engineers who take the time to understand the reasons behind everything and who have that understanding for themselves are the ones who are going to get a lot further and are the ones who are going to stay relevant with the rise of AI. And this all starts with the fundamentals. Learn how to learn. Underneath all the technical stuff though, is a skill that I think is the most important skill for engineers to have. And I think it's more important than any specific tool or language that they know really in depth. And this is learning how to learn. That is the most important skill, in my opinion. It's not Java, it's not Python, it's not a specific language, it's not being able to code super fast, because these are the things that AI can do now. AI can help anyone with. And like I said earlier, we don't know how fast the industry will change. We don't know what direction it will go in. All we know is that it will change. So you will always constantly need to learn something new. You need to be able to pick up something that you haven't seen before, be able to maybe get stuck, but then work your way through that, come to a solution and figure things out. And that cycle, repeated thousands of times, is the job. That is exactly what software engineering is. And that cycle is only going to become more pronounced with the rise of AI. This means getting comfortable with not understanding something immediately, not panicking, but realizing that you have the skills to learn something new and you have the skills to figure it out. And also being able to tolerate that in-between period where you feel like you have learnt so much and you know a lot, but so much that you realize you know nothing. And there's that weird in-between state. And the more you know, the more you realize you don't know. And this is very common for software engineers because there are endless things that you could learn. It's impossible to learn everything. So you have to get really comfortable with that feeling. Tech moves faster and changes quicker than almost any other industry. Languages evolve, frameworks get replaced, and what's considered best practice now may not be considered best practice in a few years' time. We have no idea how our industry will change and how our daily jobs will change. And AI is the most obvious example of this right now. No one could have predicted how our jobs would be right now if you'd asked them so many years ago. It has changed everyone's workflow. Even the most senior engineers who were very comfortable in their roles are now feeling like they have to start from the ground up. The engineers who struggle are the ones who learned one specific way of doing things and who refuse to adapt to new ways of working. The engineers who will get ahead or who will thrive, on the other hand, are the ones who are genuinely curious, who are wanting to learn new skills and are really okay with trying new things. Learn to read code, not just write it. This is something almost nobody thinks to practice before their first job. And it's something that really catches new engineers off guard. And that's reading code that isn't yours. I went into my first job expecting to write loads of new features and loads of new code from scratch. But in reality, what I was doing was a lot of going through existing code bases and tweaking certain bits. I spent a lot of time finding my way around code that I'd never seen before, that was written by people I'd never met. In your first job, the majority of your time will not be spent writing new code. It will be spent reading, understanding, figuring out, and modifying small bits of code that already exist. You'll be working on code that is written by someone else, possibly years ago, and possibly code that isn't very well documented. So if you've only ever written code from scratch by following a tutorial, this doesn't necessarily prepare you for the real working world. So before you start your first job, you need to build up this skill. Build the skill of being able to navigate different code bases, different unfamiliar code bases. So look at open source projects. See if you can figure out what's going on, finding the entry points, the exit points, and following the flow of the code. With AI-generated code becoming more and more common in code bases, being able to read and understand someone else's code is going to become even more important. You need to be able to read it, understand it, evaluate it, and do this all for very unfamiliar code. Learn system design. This is a skill that matters even more than before. How you architect things at scale, how different systems talk to each other, how databases are able to handle large amounts of data and different volumes, discussing and understanding the trade-offs for different design approaches. These are all things that are extremely important, and they're rarely taught at junior level. They're also the things that I think really separate juniors from seniors. And they're also the things that are going to become even more important as AI becomes more and more common. As AI handles more of the code writing layer, understanding system design moves up in value. Understanding it early puts you ahead in exactly the area where AI can't replace. You don't need to fully master it before you start, but just understanding the language and the terminology around this stuff is very useful. Just having that context of what a load balancer is, maybe how to design certain systems, thinking about API gateways and microservices. Having just that general awareness of these concepts means that you'll be able to at least understand the conversations that are going on around you, rather than it going straight over your head. Get comfortable with Git properly. A more practical one now, but it's one that often trips people up when they first get started. So making sure you're understanding the basic Git commands, your git pull, git push, git commit, and all the other commands that go with it. But beyond that, also thinking about how Git is used in that wider team environment. Thinking about your Git branching strategy, or maybe your merging versus rebasing, how to resolve merge conflicts. These are the things that are going to be very important when you work in that team environment. Maybe dedicate some time to purposely breaking things in a test environment. Try and work with different branches. Try and make sure there are some merge conflicts and figure out how you'd resolve those. It's much better to be able to practice these skills in that testing environment before working on real code bases or before getting that first role. And you need to understand Git because it's such an important part of the role. If things go wrong, there are potentially very catastrophic side effects. And you can't always just rely on AI to do this for you. You need to be able to understand it for yourself. If you rely solely on AI to do these Git commands for you, you're not having any control over what happens to your code. There are real dangers of work getting overwritten or work being lost, and that's not something you want to be responsible for. So making sure you understand Git early is the best way to prevent this. Learn to use AI tools well without letting them replace your thinking. The next one is very relevant to right now and didn't exist 3 years ago. AI tools are genuinely so useful and can definitely enhance your learning, speed up your process, and hopefully produce better outcomes. You should embrace using them because refusing to use AI is kind of like refusing to use Google. But there is also a right and a wrong way to use AI. If you're using it purely to copy and paste or to generate everything for you without fully understanding the reasons behind why it did what it did, or why it chose certain approaches and how it did it, then you're not actually improving your skills, you're not improving your understanding, and you're not going to help your career progress. It also means that you're unlikely to be learning anything new, which isn't good for you, isn't good for the team, and isn't good for the company. If you wouldn't be able to explain the code that you're submitting in a PR to someone who's reading it, then it's a sign that you're probably using AI in the wrong way. Learn to communicate technically. This last one is probably the most underrated skill. The engineers who progress the fastest in their career are not necessarily the best at coding. They're not necessarily the fastest at coding, but they're the ones who are able to communicate their ideas effectively. They're able to document things clearly, ask clear questions, able to explain different trade-offs and technical decisions, especially to those non-technical people, and they're able to communicate their value to other people. If anything, this matters now more than ever. As AI handles more of the code generation, we need those humans who are able to explain the code. We need people who are able to communicate and understand the technical side. We need those people who are able to bridge that gap. So the engineers who stand out are the ones who are able to communicate clearly and explain things in a human way. Of these 7 skills, which one of these is furthest away from where you are currently? Find where your skill gap is, choose that one, and work on it this week. If you found this video helpful, don't forget to like, comment, and subscribe. I'll leave my links in the description box below. Thank you so much for watching. Hopefully see you next time.